So what we'll do now is expand just a little bit on the concept of the tetractys, and I'd like to talk a little bit more about geometric shapes and how to make turn geometric shapes into three-dimensional form using line only. A lot of people feel in the beginning, and it's easy to feel that way or to think that way, is that you have to shade in order to create something that becomes three-dimensional. But you can actually create three-dimensional form using only line. And we'll just talk a little bit about that right now. So I've taken just a few geometric shapes here. So we have a circle, we have a triangle, we have a rectangle, and we have a square. And as you can see, these are flat surfaces. They do not have any round sculptural qualities. And I've started another line here. And what we're going to do is make these simple geometric shapes into three-dimensional form, so that in a sense, you feel they have a defined volume of space. Okay, so remember, the shape is something. The shape is, you take line, all right, and then you want to define an area in some particular way. So in this area, we started with line, we went all around, and we clearly defined an area into the shape of a circle. If you can remember in the tetractys too, we started with line, and then we defined this area, and we enclosed it so that we created a triangle. So that was the third element in drawing. The first was a mark and a dot. You begin with a point, you remove it, you have a mark and a dot. The second element was line. So we started with line here, and then we defined an area, which is the third element, to create a flat plane. It's two-dimensional. So now, coming across here, how can we take the circle, the triangle, the rectangle, and the square and make them three-dimensional? We're also going to talk about a couple of things that come up here with the rectangle and square and their situation. But first and foremost, let's begin with the circle. So this is two-dimensional right here, and what we have right here, and let me just darken this a little bit so it's a little clearer to see. And I freehand all of this. I think it's important to learn how to kind of develop your eye-hand coordination and learn how to do this to the best of your ability. I don't use any rulers or any other tools to draw, because I want the human element in my drawings. I also make a point to begin my drawings very light, so that if I need to make changes, then I'm still able to do so. If you draw too dark initially, you won't be able to do that. So back to the circle, and we have the circle here. In order for me to make this circle have and feel in a sense it's three-dimensional, if you remember, we talked earlier in the tetractys about how you create the pyramid, and actually we can do that here real quick. We'll just skip the circle and go directly to the triangle. So we have the triangle, and we had the lines of the tetractys, and if we had a point in here, and we could have combined right here, and right here to see the triangle, but I'm going to do a different version of a pyramid. So now I'm going to create a point here and a point here, and I've created a pyramid as well that's slightly different from the pyramid that was created in the tetractys. So now we have a plane here and a plane here, and adding these lines with inside it makes it three-dimensional. Okay, if you can remember before, we had done this, and then we had the section in the middle, and we created the pyramid this way. So here's two different ways to create something that's three-dimensional and change the shape into a pyramid in this format with a side plane, and then work directly inside here to create a top view, or from a bottom under looking through view of a pyramid. So a couple different versions of a pyramid. And next, we can also take this exact same shape here of the triangle. Let me just freehand this here really quickly. And there's one more three-dimensional form that can be created by adding an ellipse here at the bottom. We have now found another way to make this a defined volume of space, to make it three-dimensional, and now we have a cone. So we have the triangle, which is flat. We still have the triangle. We added a second plane, and this made this become a pyramid. And then we also did the third variation of the pyramid, or I mean the second variation of the pyramid, the third variation of another form right here with the cone. So we have three variations: pyramid 1, pyramid 2, and then we have a cone. All of these are three-dimensional forms. They all have a defined volume of space. The circle. A lot of people find this really challenging. How do you make a circle become three-dimensional without shading it? Because a lot of people, at some point, and we will do that as well, you'll have to shade a sphere to learn the elements of shading. That's a very classic way to learn how to shade. But how would you do this with line? Well, you can follow this example here that we had of adding the ellipse to the cone. And if we add the ellipse inside the circle, so I'll add it around it here as if we were drawing a line around the circle. And then I will add another ellipse coming through this way. And I'm going to add an additional ellipse coming through here. And again, I make sure to start very light, and I'm just freehanding this. And it takes a lot of practice to start to be able to control your pencil. But now, as you can see, by adding these ellipses inside this shape, so here we have the circle, which is a shape, but once we start adding these ellipses inside of the shape, it now starts to define a volume of space, and we now have three-dimensional form. Just clean that up a little bit right there. So this is two-dimensional shape, three-dimensional form. A two-dimensional triangle, a three-dimensional pyramid, a three-dimensional pyramid, and a three-dimensional cone. And what this now brings us to the rectangle. So here, this is a flat plane. And now what I've added here is we have two more rectangles. And it's an interesting question, is this three-dimensional at this point? It is actually not three-dimensional. What it is we have two rectangles, which are two shapes that are layered one upon the other. So at this point, they are not three-dimensional. These are two-dimensional shapes stacked one upon the other. In order to make this three-dimensional, which we can easily do, is just a matter of working inside the shapes and then connecting them. So if I connect this here and here, and I connect this here and here, now we have created a three-dimensional form. It has distinct volume. So now this is flat. This is now cube-like. Taking the two-dimensional what we had is just the two-dimensional shapes. We had two of them, and we connected them together, and it has now created a situation where we have a defined volume of space. Our geometric rectangle has now become a three-dimensional cube. All right, the next thing we can do, because there's another variation of this, and it's taking the similar idea here of the cone, and if we add two ellipses here, and we'll add a second one down here, and I'm keeping this as light as I can and trying to just freehand it using eye-hand coordination. And then I'm going to now start to clean it up a little bit. So now taking this very idea of a flat shape, a rectangular shape, we've created a three-dimensional cube and a three-dimensional cylinder. All right, so we've taken the ellipse here and connected it to two parallel lines, and then we now have a cylinder. Lastly, in terms of the geometric shapes, we have here, this is flat, it's a square, and I have the same as we had before. We had two planes. In this particular case, I'm going to leave these as planes so that you can see them separately. But very distinctly, this is a plane right here. And then behind it or in front of it, either way, it creates an optical illusion. We have a second plane. They're not connected in any way, so it is not three-dimensional. You have to think of it abstractly as two separate shapes. But I've drawn it again here, and we're going to do the same thing we did with the rectangular cube. We are now going to connect these lines. And if I were to just leave it like this, it creates an interesting situation, because if you look at this, is this actually a three-dimensional form? At this point, it is not, because you have a plane that comes up here, then you have a top plane that comes here, and then we have a back plane that comes here. But it is not fully connected, so it's not solid. So it is not a defined volume of space. Now, if we connect this here, and we connect this in here, it is now fully connected and forms a complete cube. Okay, so as you can see here, we have two-dimensional shapes. And by comparison, when you look between this and this, you can see that this is definitely flat. It does not have volume. It is not three-dimensional. This, we added the lines with inside the shape to help define the volume to make it three-dimensional. Same here. This is flat. This right here is technically flat, and we added a side plane, which in a sense is just two planes because you can't see through. If we wanted to do this correctly to make it three-dimensional, I would go across here and add that third plane. And then we have now another set of planes, and we come down. And we can have this line coming across here. And as if you can see through, we have this back plane now. This back plane, and you can see that these lines coming across in here create perspective. So you could be looking through and seeing the floor area. So now we have a three-dimensional pyramid, but it's entirely different from this. This one we're looking directly in, or we're looking at an aerial view. Whereas this is a three-dimensional plane that is side view. So how we did this right here, where we added the lines with inside the form, now we have added the lines inside the form and then connected them there so that we see the pyramid. Then we have the cone with the ellipse. So these are the different variations of the triangle. We have the pyramid seen from the side. We have the pyramid seen from either the bottom or the top. And we have what has transformed the triangle shape into an actual cone. Then we come down to our rectangle. We had, if you recall, we had two separate rectangular planes. We connected them all together and formed a cube. And then here we started with two parallel lines and then added two ellipses, very similar to the cone. And we now have a three-dimensional cylinder. So we had the square. We left this as two separate planes so that you can see that how this works out. They are both flat and they are just layered. But when we redrew it here on the side, we connected all the elements. And we now have three-dimensional cube. So this is a discussion on geometric shapes. Let me get that on here. As opposed to organic shapes. How do you turn geometric shapes into form using line only? Later we'll be talking about how you can take these shapes and shade them to make them three-dimensional, but using line only, this is a process that can be done to make shapes three-dimensional without shading.